Let's find the derivative of sin x. So we have f of x is equal to sin x. Now, what will we use? Correct. As per the first principle of derivative. So we are looking at f prime of x is equal to limit f of x plus h minus f of x, this entire thing divided by h, as h tends towards 0. Now, f of x plus h is what? It's always best to simplify f of x plus h first and then think about finding the derivative of f of x. Now, we have sin x, and so in place of x I'm putting x plus h. It has to be inside the brackets and we will need to expand this. So clearly this is sin a cos b plus cos a sin b. So let's substitute this onto our first principle. So substituting in 1. So what we have here is f dash of x is equal to limit, and then we have sin of x into cos of h plus cos of x into sin of h, and we have minus sin of x, that is the last term, and this entire thing divided with h. Agree? Now, there's one thing that we need to do. First thing is we need to take common between the first and the last term. So what is common? Yes, sin is common. We have sin of x, that is common, and what is left out inside the brackets? Cos of h and minus 1. Agree? And what is the other term? Cos of x into sin of h. Now what I am doing here is I am going to use the limit property, that I can apply limit to individual functions when we have addition or subtraction as an operation between them. Right? We can do this. So I'm going to apply the limit to this as well. This entire expression divided with h. Now we need to make a small observation actually. So let me take a line for that. Okay, this is good enough. Now, see, this is what is varying over here. We have this to be varying, that is h. What about x? Well, x is not varying, first thing, and x is independent of h obviously. So as a whole, as an expression, sin of x is independent of h. Do you guys agree? And over here, cos of x is independent of h. So these two expressions are independent of h. That is, they are not going to vary. So if they're not going to vary, I can, as per the property of limit, I can take it out. Right? They'll act like constant. So here they will be equal to a constant. If they're not varying, we can take it as a constant. And so, end of it, I can take out sin x out of the brackets and apply the limit only to whatever is going to vary. So this as a group, of course I can't take it out, and cos x, and we have limit sin h as h tends towards 0 divided by h. See, as a whole, what happens over here? This is nothing but 0 and this is nothing but Yes, this is as per our standard results. So the first term is 0 and the second term will be, this will be 1. And 0 into anything is 0, and cos of x into 1 is cos x. So basically derivative of sin x is what? So f dash of f prime of x is equal to cos of x. So that would be your derivative of sin x. Let's look into a visual proof. Let's take a visual proof. Now we are looking at a function and its derivative. So first thing first, let's start off with, say 0. Okay, this is pi by 2 into 0. So this is 0, this is 90, this is 180, 270, and so on and so forth. So we're looking at two graphs. One is a function and another is its derivative. The y component is varying from 1 to minus 1, and here too it's 1 to minus 1, and the x is varying from minus pi to 2 pi. So this is basically minus 180 to 360. So this is 0, this is 90, this is 180, 270, and 360. That's how it's varying. So we know that sine 0 is 0, but the slope is in an increasing phase, right? And this happens to be 1. So I'm going to take this value and plot it over here. So basically this graph shows the value of the slope throughout. So at pi by 2, the slope we can see it's clearly 0. So I'm going to plot over here 0. Can you see that? It's 0. And over here, that is at 180 degree, the slope is decreasing. It is negative, right? It is negative and it is equal to minus 1. The slope over here is 45 degree. No, it actually is 90 plus 45 degree. So basically it is minus 1. So slope over here is minus 1 and I'm plotting minus 1 over here. And at 3 pi by 2, 270 degree, the slope again is 0. So I'm going to plot 0 over here. And if I keep doing this, I get this particular graph. So let me take a snapshot of this. And let me show you guys something which you guys are familiar with. I'm trying to connect things so that it will make sense to you guys. So let me erase this off. I don't need this. And I have over here, say this is your x-axis, this is your y-axis, and that's your x-axis, and this is your x-axis. So this is your 90 degree, 90 into 0, that is 0. This is 90, this is 180, and this is 270, and this is 360. So what kind of graph is this? Can you see that? It starts from 0 to 1 and back to 0 and minus 1 and 0 again. So this is clearly sine of theta. What is this graph? It starts with 1, then goes to 0, minus 1, 0, and 1 again. This is clearly cos theta. And we had a visual proof that the slope at different points, we can clearly see again. You guys can do this. So if I happen to go back, you can see the slopes over here. It is 1. And over here, the slope is 0. And over here, the slope is minus 1. And over here, at an angle of 270 degree, it is 0. Right? So basically, the derivative of sin x is cos x. This is your visual proof. Okay. Now you can pause and you should copy all of this. Don't miss anything. Even the ones which I have written in lighter note, even that has to be copied.